The equation of curve, if they give this to you, you first off recognize that y is equal to x squared minus 6x plus k. This is an undefined curve, meaning it's going to be a quadratic parabola, right? You know what parabola looks like. You see the number in front of the x squared. Just explain to you the awareness you need to have. You know this is going to be a smiley face parabola because number in front of this. Confirm you understand why if the number in front of the x squared is positive, it's definitely going to be a smiley face parabola. You understand this component proves that it's going to be a smiley face parabola, and the plus k over here is just telling you that curve could be in any position right now. You've got a smiley face parabola that could be anywhere on the curve right now. That's what it means, okay? So this is an undefined parabola. It's indicating the k over here, because it's undefined, because you haven't put an actual number over there, it's going to be a parabola that's anywhere, a smiley face parabola anywhere on a curve. And they're trying to ask you to describe what does k have to be, what is this number allowed to be, so that it definitely lies above the x-axis. Why would you know this is going to be a discriminant question? Like, how would you know this is the work you need to do? Think about it this way, okay? If you have a parabola like this, remember the three main scenarios that can happen? It can be either above the axis, it can be touching the axis, or it could be what? Touching the axis at one point. Do you see that this illustrates the general three ways in which the curve can touch the x-axis? Yeah. Now my point is this, right? If you were to make x squared minus 6x plus k, this is what they're really testing on over here. They're testing on, hey, do you recognize x squared minus 6x plus k equals to 0? It's illustrating, hey, how do we find the x-intercepts? How do we find the number of solutions for which this touches the x-axis? Because that's what this equals to 0 means, doesn't it? Whenever you're dealing discriminant is equal to, whenever you're dealing with quadratic equals to 0, like when you make x squared minus 6x plus k equal to 0, remember this is really just asking you to find the points of intersection with the x-axis, the x-intercepts. And remember that the triangle, the discriminant, is just a method where you can tell how many points it's going to touch the x-axis in. Is it going to touch in 2 points, 1 point, or no points? Remember the basic discriminants over here? From this principle? From this tutorial over here? Like, why we even care? How it's used in the exam questions, yes? It can be used to tell how many points where it's going to touch the x-axis. So when they say it's going to lie above the x-axis, this is the whole curve, aren't they basically saying to us, hey, can we tell that lying above the x-axis is implying that the curve doesn't actually touch the x-axis? It's going to what? Not have any x-intercepts. So if you realize there's not going to be any x-intercepts, it's the same thing as saying the discriminant is going to be less than 0. Because in order for this to not have solutions, the triangle would be less than 0, isn't it? Whenever the triangle is less than 0, this question turns out to have no solutions, no answers. Do you follow this principle over here? Do you realize why we have to make discriminant less than 0? Because that's how we describe the relationship where this is not going to have an x-intercept. Above the x-axis just means no x-intercept. Okay? And that's why we just do this now. Because if you know discriminant less than 0, well, wouldn't it help to find a discriminant? That's the whole point of this tutorial, isn't it? Like recognizing when the discriminant even exists. It clearly does exist over here. We need to deal with the discriminants. How do we find the discriminant? Well, we can always find it by listing the a, b, and c coefficients first, and then setting up the discriminants. The rest is just doing basic algebra. Why do I say basic algebra? Because you know b squared minus 4ac means, well, what's b? We know that b in this context is negative 6, so we replace the b with negative 6. So negative 6 squared is obviously going to be 36. Right? We're just doing the basic algebra here, translating this into the actual numbers. This is going to be substituted into the c. This is going to be substituted into the a. 4 times a times c. 4 times 1 times k. Minus 4k over here. Minus 4ac. So you know how this becomes this. And of course, once you see this, this is just a basic inequality, isn't it? Negative 4k less than negative 36, which is what's happening over here. The reason why we change the sign, remember this basic rule over here, in case you're confused. You shouldn't be, but in case you are confused, let's look at a basic example of if 5 is bigger than 0, we know that's correct. What happens if we multiply both sides by negative 1? It's going to be negative 5 and 0 over here. What happens if we don't change the sign? Oh shit, is negative 5 really bigger than 0? No. How would it be correct? It has to be negative 5 less than 0, doesn't it? So do you see the point? If we multiply both sides by a negative number, or if we divide one of the numbers on the other side, but it's a negative number divided on the other side, we have to change the sign. Check this out again too. Imagine if you had negative 4 is greater than negative 10. That's correct. Negative 4 is indeed bigger than negative 10. Think about it. If you owe someone $4, is that better than owing them $10? Of course. So if you divide both sides by negative 1, does that mean negative 4, the negative 1 over there divided to the other side becomes, so 4 becomes positive, negative 10 becomes positive. What happens if you don't change the sign? Oh shit, it's going to be math error, isn't it? Like, that's blatantly incorrect. 4 is not bigger than 10. 4 is less than 10. Do you see why we had to reverse the sign? Reversing the sign makes it actually true, mathematically correct. This is just illustrating the basic rule about why we have to reverse the sign for the inequalities whenever we divide both sides by a negative number. And that's where we get the answer k is bigger than 9.